Okay, welcome back everyone to these tutorial videos. So in this video, I'll be talking about the procedure of removing epsilon productions from your context-free grammar. So remember, if I have a context-free grammar, G, and I have some variables, and imagine that, some of the production rules in my context-free grammar G contain the epsilon production rule. Right? So maybe each of them, right? So, S has the rule, S gives me epsilon, so there's A, B, and C. And the pipe here is just to show that on the left and on the right, I might have more production rules, right? So then what I want to do in this procedure is I just want to get rid of these guys, right? I want to get rid of these production rules. And why do I want to do this? Because what we're trying to do is we're trying to work our way towards a general procedure to convert a grammar into Chomsky normal form. And so if we go back up, we see that in Chomsky normal form, production rules must either look like, a variable on the left-hand side and two variables on the right-hand side, or, of course, a single variable again on the left-hand side, just because it's a context-free grammar, but then a single terminal on the right-hand side. And so both of these cases do not sort of admit the possibility of having the epsilon on the right-hand side, okay? So essentially, because otherwise do not have Chomsky normal form, right? So what we're going to do is we're going to see how we can completely remove all epsilon production rules while preserving the sort of language generated by the grammar. Of course, small caveat, right? Small caveat is what if, so the small caveat is what if epsilon is in the language generated by the grammar? Then almost by definition, if you remove, right, almost by definition, removing all the epsilon productions from your grammar means that you no longer preserve the language generated by the grammar, because now your converted grammar, your simplified grammar, can no longer generate the empty string only, right? And so that's typically a problem if, right, if you want to ensure that, so if you care about L of G being the same as L of G prime, then typically we just add back S gives you the epsilon rule, right? But if you just care about sort of, if you just want to convert the grammar into, say, Chomsky normal form, then you can just say, well, I'm just going to sort of lose this empty string generation, and I'm still going to have, other than the empty string, the same generated language. Okay. So if not, then just drop it. Right. Okay. So now I'm just going to quickly present to you or review with you really the algorithm. So the thing I want to quickly define is, so we know that epsilon productions, right? So epsilon productions are production rules of the form, some variable, and then on the right-hand side, epsilon, right? So what this sort of procedure requires is it requires the definition of nullable variables. So we say that a variable is nullable if there's, with some number of steps, a way to go from the variable A to epsilon, right? So what that means is if in my grammar I have something like S gives me a bunch of production rules, then I have S gives me AB, and A gives me epsilon is in the production rules for A, and B gives me epsilon is in the production rules for B, then of course A and B are nullable variables, but actually so is S, right? Because I can do something like A derives AB, and then A gets replaced by epsilon, and then B gets replaced by epsilon. So then I have S gives me epsilon in 3 steps, right? So then these 3 guys would be nullable variables. Okay, so whoops, I already have my example, but I need to explain a bit more. Oh, oh no. Oh, thank goodness. Okay. Uh, okay. Add page, don't delete the page. All right. Um, so what was I saying? Yes, right. So now I've defined nullable variables, and now that's how I can actually start to define the procedure. So the procedure to remove epsilon productions is, well, the first thing I want to do is I want to identify all nullable variables, right? And let's just say I just put them in some set of variables that's called Vn, right? Um, right. Then the second thing I do is, so what I'm doing, so my input is some context-free grammar G, and my expected output is some other context-free grammar G prime, right? So the second step is to add all non-epsilon production rules to G prime, right? So to G prime. And then what I want to do, right? Then what I want to do is I want to somehow account for all of the epsilon productions, right? But what do epsilon productions actually give you in the end? They just give you a way to, at some point, have a variable, and then at the very next step, have that variable sort of disappear, right? So you can imagine, like, if suppose that A was nullable, right? Then imagine I had started my derivation rule with something like S, and then I had some stuff, and then I had something like I had an A at the beginning, then some strings, and then a B, and then another string, right? Then nullability, right? The fact that a variable is nullable just means that at some point I can make this thing disappear, right? So I can just say, well, A gives me A, B, B, C. Right? Okay, well, the idea behind this algorithm is instead of having to go through the variable A to actually make it disappear, just make it disappear to begin with, right? So in other words, just allow for S to go directly to this guy, right? So I think this would be even clearer if it was the very first rule that I had used, right? The very first rule that I had used was S gives me AAB, BC, right? Then what's eventually going to happen, right? Or what could eventually happen is A could get replaced by epsilon. And so in that case, if that's a possibility, then if I just remove A gives me the epsilon rule, what I just need to do to preserve the strings generated by the grammar is to just preserve that eventuality of replacing A with epsilon at some point, right? So in other words, I just have to I have to sort of, if I'm removing A gives me epsilon, then I just have to I have to sort of hard code in this production rule of S gives me A, B, B, C, right? So that's exactly what I'm going to do in step 3. So step 3 is to add to G prime every possible non-epsilon production rule, right? Because you don't want to add back production rules. Non-epsilon production rules, whoops, rules resulting from replacing uh, some nullable variables, or by yeah, sure, okay, by replacing some nullable variables in a rule R in P prime with epsilon. Okay. So, okay, what does that mean? What does that mean? That's a bit wordy. Really, what that just means is suppose these three guys were all nullable variables. And I had in my grammar, I had the production rule something like A, B, C, right? Then what I want to do is I want to say, well, I have this original production rule, so this is in P. Now what I want to do is I want to account for the fact that I could have so I can have sort of other production rules that just result from actually using these the nullable production rules of A, B, and C respectively, right? So that means I have to account for the fact that any of these guys, one or more, could get replaced eventually by epsilon. So that means that what I need to do is I need to add in P prime, I have to add S gives me, AB, because that would be C getting replaced by epsilon, then BC, because that would be A getting replaced by epsilon. Then there would be, what else would there be? AC, right? That would be B getting replaced by epsilon, and then the individual ones, right? So A, B, and C. And of course, right? That's why I sort of said this. Add every possible non-epsilon production rule. So of course, it's possible that I replace A, B, and C by epsilon, but then I would just be adding back the epsilon rule into S in this case. So I just don't add that rule. Okay. And I just do this for every possible production rule that has at least one nullable variable. Okay. So hopefully that's clear. It still might not be, in which case I don't blame you. Maybe the fact that I'm standing and so full of energy is distracting. So to make this a bit easier, we'll try to run through this example which I've written down for us. Okay. So I need to remove not the nullable variables. Look, don't remove the variables. I just want to remove the epsilon productions. And not for G, but from G. Boy. Okay. And I want to do not just some. I want to remove all. Whoops, 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 whoops. Remove all. Okay. So remember, what's the first thing I need to do? Well, I want to identify all nullable variables, right? So which of these guys are nullable variables? Well, definitely C and A, right? That's for sure. So C and A. Now, are there any others, right? Are there any others that I can get to uh, for sort of at a second step? So S is definitely not going to be a nullable variable because all of its production rules, in this case, it just has one, but all of its production rules have at least one term, right? So even if these three guys were nullable, then I would still have A at the end. And so I wouldn't have something like S gives me epsilon. So that's a no. But it does look like I have B gives me C, right? So if I have B gives me C, then I can at some point replace C by epsilon. And then that means that I can get in any number of steps to epsilon from B. So that means that B as well is a nullable variable. Okay, great. So now let's add all the non epsilon production rules to the new grammar G prime. So G prime is going to be S A B C, A B C, B B B, and then C C. And then, right, so that's step two. And then step three is just going to be me replacing every possible combination of nullable variables with epsilon in every production rule that does contain at least one nullable variable, right? So what is that going to look like? Let's just copy this guy. Copy, paste this guy here. Okay, so which of these has a nullable variable as well? It looks like it's all of them, right? So A, B, C are all nullable variables. So let's account for this for S. So I can replace, like I said, A with epsilon and so on. So let me just write those out. And C, and then I can replace two. So A, B, C. And in this case, right, in this case, it's actually okay if I replace all three because I don't end up with an epsilon production rule. Right, so I get A. Okay, cool. And then I can do the same thing for this production rule. So I replace B with epsilon, C with epsilon, but now I don't replace both of them with epsilon because I don't want to add an extra epsilon production, right? And it looks like that's it, right? So this is the production, this is the simplified, right? It's actually not, it doesn't, at least to me, this is not what I would say is a simpler grammar, but it's the sort of simplified version of the grammar. Oh, I might have actually, I'm sorry. Okay, I might have missed, so I missed this guy, right? When copying this down. So this had to go here. And then, right, I think I might have just missed it because I was thinking, oh, it's a nullable variable, but this is just, it just stays as C, right? I don't add the replacement with epsilon because otherwise I would get B gives me epsilon. Okay, so now this looks right based on my solutions. So I'm happy. Hopefully you are also happy with this procedure for removing epsilon productions. And so I'll see you in the next video where I'll do some more simplifications.